So we're going to look a little bit about three-dimensional space and how that works in math and how that will apply to vectors. So normally we have an xy plane and we can go over x and up y, typical Cartesian planes. So what I'm going to look at today is what if we have 3 dimensions. So the way we do that is we essentially will add a new axis. So I'm going to draw 2 axes on here. So generally we make our x go this way and our y-axis go this way. So if you look at this, this is essentially 2 axes. So the way we orient it is generally we say this is positive and this is a negative direction for x. This is a positive direction for y, and this is a negative direction for x. So essentially, if you flip it like this, we're kind of looking, this is what our plane looks like. We orient a little different because we essentially, because we'll add a third axis, we want to see what comes toward us. So if I look at just like the point 22, this would be the point 22. Over 2 for x, up 2 for y. So this would be the 2-dimensional point 22. But obviously, since we're doing 3 dimensions, we need to add another axis. And we add it typically going this direction. So this is the z-axis. And this would be the negative direction for that. So now we have 3 space. So if I want to plot a point in 3 space, let's pick a point. Let's say I want to pick the point 2, 1, 4. So I'm going to go 2 spaces on the x-axis. So here would be my second one on the x-axis. I'm going to go 1 in the y direction. So that would be here. So here, this space here, this is my point 2, 1, over 2, up 1. So now I have to go on the z-axis 4. So I'm going to go in this direction, so toward it. So 1, 2, 3, 4. So this point here, this is going to be my point 2, 1, 4. So it's over 2 in the x, towards y 1, and then up 4. Now obviously when you're drawing 3-dimensionality in 2 dimensions, it has some challenges, so this is kind of the best way we can look at these points. Let's do one more just real fast. Let's do the point -2, 3, and then, I don't know, -2. So we're going to go x is negative, so that is this direction. So there's -2. Y is 3, so I'll go toward the y3 because it's positive. And then I'm going down 2. So going up would be positive, so going down would be negative. So this is that point here. It almost lies on the y-axis. It just appears that way, though, because if you think about it, it's below the y-axis. It's kind of in this over, and down. But in 2-dimensionality, it kind of looks like it is on that axis. But that is where that point would be. Let's do one more. How about 2? I keep doing 2. Let's do 3, -2, -1. So we go 3 toward the x-axis. We'll go -2 on the y-axis, so backwards y. We always go parallel to its axis, and then down 1. So that would be that point there. So it is over to the left, kind of toward us, backwards, and then down. So if you think of this as the xy plane, this point is below that plane. So if you think of like the table as your point, this point would be below the table. So that's how we graph ordered triplets, how we graph points in 3-dimensional space.